2.7 degrees above absolute zero. That is the ambient temperature of the deep vacuum. In this freezing, irradiated darkness, a single photon of infrared light detaches from the collapsing core of a primordial star. It begins its trajectory through an expanse of space so profoundly empty that a lone hydrogen atom could drift for 1 billion years without ever colliding with another. This photon travels in complete silence, carrying the dying signature of an ancient galaxy. For the first few million years of its journey, it navigates a sprawling graveyard of dark matter and unformed cosmic dust. It does not stop. It does not slow down. It moves at the absolute speed limit of physical reality, crossing nearly 6 trillion miles every single year. By the time this solitary, exhausted particle of light finally crashes into the gold-plated beryllium mirrors of the James Webb Space Telescope, it has been in continuous flight for over 13 billion and 300 million years. It has outlived entire generations of star systems. It has traveled for so long that the Earth itself did not even exist for the first 9 billion years of its journey. But the sheer duration of this flight is not the anomaly. The anomaly is the terrifying reality of the physical distance it represents. Because while that photon was sprinting across the void, the fabric of the universe was not standing still. Space is not a passive, static theater where objects merely exist. It is an active, aggressive membrane that is constantly stretching, pulling galaxies apart in every conceivable direction. The dead star that birthed this light is no longer 13 billion light-years away. The relentless expansion of reality has violently dragged its corpse outward, pushing it to an unfathomable distance of over 33 billion light-years from your current location. To comprehend a distance this severe, we must strip away our biological intuition. If you were to board a spacecraft moving at the exact speed of the fastest machine ever engineered by human hands, the Parker Solar Probe, you would be traveling at roughly 430,000 miles per hour. At that blistering velocity, it would still take you over 8,000 years just to cross the desolate, sensory-deprived emptiness between our Sun and the very next neighboring star. Scale that up. To cross the disk of our own Milky Way galaxy at that maximum human speed would require nearly 2 billion years of solitary confinement in the dark. And yet the Milky Way is nothing but a microscopic, insignificant speck of dust suspended in Laniakea, our local supercluster, which itself is just a minor fading thread caught in the grander cosmic web. Consider the Boötes Void, a spherical region of the universe spanning nearly 330 million light-years in diameter. It is a sector of space so aggressively hollow that if our solar system were placed precisely in its center, the night sky would be pitch black. We would not have even known other galaxies existed until the invention of advanced radio telescopes in the 1960s. It is an ocean of absolute isolation, a physical abyss where the density of matter drops to almost zero. This is the architecture of our environment, a structure of distances so catastrophic that they shatter the processing capabilities of the human brain. But the true dread of astronomical scale does not come from simply writing down large numbers on a chalkboard. The existential friction lies in a mathematical contradiction hidden deep within the physics of this expanding volume. When astrophysicists map the observable edge of reality, measure the density of the matter within it, and calculate the forces required to govern a structure of this magnitude, the equations fracture. The sheer physical size of the universe is in direct, hostile conflict with the fundamental laws of geometry and mass as we understand them. The numbers reveal a dark, irreconcilable truth about the space we occupy, a structural paradox that suggests the cosmos is not just larger than we can imagine, but behaving in a way that makes absolutely no sense. Human intuition is a highly specialized, entirely terrestrial survival mechanism. It is a biological operating system designed specifically to navigate a limited three-dimensional grid defined by gravity, friction, and immediate physical threats. We evolved to calculate the parabolic trajectory of a falling rock, to gauge the distance of a predator across a sunlit savanna, and to measure the passage of time by tracking the shadow of a rotating planet orbiting a totally unremarkable local star. Our neurology is hardwired to expect space to be a passive, unmoving container, an empty, silent room where objects transition from point A to point B, while the room itself remains perfectly still. When we try to force this primitive biological software to process the actual mechanics of the universe, the system crashes. For centuries, even the most brilliant minds on the planet were completely captive to this biological arrogance. In the early 20th century, the consensus among the scientific elite was that the universe was eternal, static, and relatively small. The Milky Way was believed to be the entirety of existence, suspended in an unmoving void. When Albert Einstein published his field equations of general relativity in 1915, laying out the gravitational architecture of reality, he encountered an immediate, terrifying problem. When he applied his own flawless mathematics to the entire cosmos, the equations rebelled. The math insisted that a universe filled with matter could not remain frozen in place. It had to be in motion. The gravitational attraction of all the stars and gas should cause the entire structure to collapse in on itself, crushing reality down into a single point of infinite density. Einstein found this mathematically inescapable conclusion so philosophically disturbing, so fundamentally offensive to his human intuition, that he altered his own theory. He introduced a mathematical fiction, a theoretical counterbalance called the cosmological constant, purely to force his equations to balance out. He engineered a deliberate mathematical lie to keep the universe standing still. But the universe does not care about human comfort. It required only a few years, a cramped room at the Harvard College Observatory, and cold observational data to dismantle Einstein's static illusion forever. To map the true geometry of the dark, physicists needed a reliable ruler. They found it through the agonizing microscopic labor of Henrietta Swan Leavitt. In an era when women were strictly forbidden from operating the observatory's large telescopes, Leavitt was assigned to examine photographic plates of the night sky. She spent years in silence, staring at thousands of glass squares, analyzing the microscopic smudges of starlight captured on the emulsion. Her focus was on a specific volatile classification of dying suns known as Cepheid variables. These are highly unstable stars that physically pulsate. They rapidly expand and contract like a hyperventilating lung, and as they do, their surface brightness fluctuates in a rhythmic, predictable pattern. Through raw statistical analysis, Leavitt discovered a relentless mathematical rhythm buried in the chaos of these dying stars. She realized that the longer a Cepheid took to complete one cycle of pulsation, the brighter its true intrinsic luminosity was. This was not a mere astronomical footnote. It was the master key to the vault of cosmic geometry. If you know exactly how much light a star is actually producing at its surface, and you measure how dim that star appears from a telescope on Earth, you can use the inverse square law of light to calculate precisely how far away it is. Leavitt had discovered the standard candle, a perfectly calibrated lighthouse burning in the cosmic fog, allowing humanity to measure deep space. In 1923, astronomer Edwin Hubble aimed the massive Hooker telescope on Mount Wilson, a 100-inch glass mirror suspended in hundreds of tons of cold steel, at a hazy patch of light known as the Andromeda Nebula. Within that glowing smudge, he identified a single Cepheid variable star. Applying Leavitt's mathematical ruler, Hubble calculated the distance to this pulsating star. The numbers delivered a lethal, decapitating blow to the human ego. The star was not inside our galaxy. It was millions of light years away. Andromeda was not a localized cloud of dust. It was an entirely separate, unfathomably massive island of stars, floating in a void far larger, far colder, and far more isolated than anyone had ever dared to calculate. The Milky Way was instantly reduced from being the center of reality to a random, insignificant speck of dust, drifting in an unimaginably vast ocean. But the data extracted from Mount Wilson revealed something far more violent than just extreme distance. As spectroscopists broke down the light arriving from these newly discovered distant galaxies, they noticed a severe structural deformity in the photons. The light waves were stretched, elongated, and dragged down into the red, lower frequency end of the electromagnetic spectrum. This redshift, was not the result of galaxies flying outward through static space like shrapnel from a chemical explosion. The reality was far more insidious. Space itself was generating new physical volume. The vacuum between the galaxies was actively multiplying, stretching the fabric of reality and dragging the galaxies along with it. Imagine a vast, infinitely extending three-dimensional grid constructed from dark, solid iron. Now imagine that every passing second, a new inch of iron simply manifests out of absolute nothingness, wedging itself between the existing bars. The objects resting on the grid are not moving relative to their local space. The grid itself is forcibly stretching them apart. This is the metric expansion of the universe. It is a relentless, physical swelling of the vacuum, a phenomenon that guarantees that the night sky we see today is the most crowded it will ever be, and that every second that passes pushes the outer edges of reality further into unreachable obscurity. This discovery was so profound that it established the foundation of modern cosmology. The universe was expanding, it had a beginning, and it was growing. But gravity, the collective gravitational pull of hundreds of billions of galaxies, dark matter, and black holes, was expected to act as a cosmic brake. Astrophysics dictated that the expansion of the universe had to be slowing down, exhausted by the relentless inward drag of its own mass. To measure exactly how fast the universe was decelerating, astronomers in the late 1990s looked for the most violent luminous events in the cosmos, Type Ia supernovae. To understand a Type Ia supernova, you must picture a white dwarf. It is the ultra-dense, glowing corpse of a dead, sun-like star crushed by its own gravity until all of its mass is compressed into a sphere no larger than the Earth. If this dead star happens to orbit in a binary system with a larger, bloated companion star, it acts as a gravitational parasite. The white dwarf ruthlessly strips hydrogen gas from its companion, funneling the stolen matter down onto its own surface, packing it tighter and tighter. The dead star builds immense pressure until it hits a very strict mathematical threshold, known as the Chandrasekhar limit. The moment the white dwarf reaches 1.4 times the mass of our Sun, the quantum mechanical safeguards that keep the star stable instantly fail. A runaway thermonuclear fusion chain reaction ignites, ripping through the carbon core in a fraction of a second. The dead star detonates. The explosion is so catastrophically violent that for a brief window of time, a single, microscopic point in space outshines an entire galaxy of 100 billion stars. Because the physics governing these detonations are identical across the cosmos, because every single white dwarf explodes at the exact same mass threshold, they all peak at the exact same absolute brightness. Like Leavitt's Cepheids, they serve as perfect cosmic yardsticks, but ones so aggressively bright they can be seen across gulfs of space spanning billions of light years. Astronomers tracked the light from these detonating white dwarfs to measure the deceleration of the cosmos. But when the data was processed, it produced a profound, chilling violation of the laws of physics. The expansion of the universe was not slowing down. The expansion was accelerating. Some invisible, pervasive pressure, an energy field embedded deeply within the vacuum of space itself, was actively overpowering the gravitational binding energy of the entire cosmos. We label it dark energy, a placeholder name for an entity we cannot see, cannot touch, and fundamentally do not understand. It is a repulsive force that grows stronger as space expands, pushing the fabric of reality apart faster and faster every single day, guaranteeing a future where the universe tears itself into absolute, frozen isolation. And this relentless acceleration brings us directly to the present day, to a mathematical fracture that currently threatens to tear down the entire hard-won framework of modern physics. We call it the Hubble Tension. It is the epicenter of the existential terror of modern cosmology. When astrophysicists attempt to measure the exact speed at which the universe is currently expanding, known as the Hubble constant, they essentially have two separate, highly precise methods of investigation. The first method is to look at the ancient universe. We use deeply cooled orbiting observatories like the Planck satellite, chilling its sensors to -270 degrees Celsius, just fractions of a degree above absolute zero. In this frozen state, it captures the faint microwave radiation left over from the immediate aftermath of the Big Bang, a phenomenon known as the cosmic microwave background. By analyzing the microscopic temperature fluctuations in this primordial light, scientists can observe the exact density and composition of the universe when it was just a raw 380,000-year-old plasma. From these initial conditions, they run the standard model of cosmology forward, calculating what the expansion rate should be today. The mathematics are rigid. They yield a very specific, stubborn number. The universe is expanding at roughly 67 kilometers per second for every 3.2 million light-years of distance. The second method is to measure the modern local universe right now. We use our most advanced modern optical observatories like the Hubble and James Webb Space Telescopes to look at the Cepheid variables and the detonating white dwarfs we just discussed. We physically measure the distances and the redshift of the galaxies moving away from us in real time. The instrumentation is flawless. The margin of error has been relentlessly aggressively eliminated over decades of peer review. When we calculate the expansion using the modern universe, the math dictates that space is expanding at roughly 73 kilometers per second for that exact same distance, 67 versus 73. To a biological creature walking on Earth, a difference of 6 kilometers per second might seem like an irrelevant rounding error. In the unforgiving machinery of astrophysics, it is a catastrophic, irreconcilable paradox. Both measurements are considered completely accurate. Both machines are working perfectly, and yet the numbers fundamentally disagree. The universe is physically expanding faster locally than the physics of the early universe dictate is mathematically possible. This is not a mistake in the calculation. This means there is a fatal flaw in our understanding of reality. There is an unknown force, a phantom energy, a rogue particle, or a completely broken gear in the gravitational machinery of the cosmos that we are totally blind to. We are currently staring into the abyss of a universe whose dimensions and behavior are actively warping under a set of physical laws that we do not possess. The rules we use to build our understanding of existence are incomplete, and the dark matter and dark energy dictating the flow of the cosmos are operating on a frequency we cannot tune into. We are navigating a collapsing paradigm. The deeper we peer into the dark, the more the foundational structures of our reality begin to unravel, exposing a cosmos that is entirely indifferent to our logic and profoundly hostile to our biology. The pursuit of these astronomical truths requires stepping completely out of the light of human comfort, accepting the cold, violent isolation of the facts without flinching. If you seek the truth in the dark, if you are willing to face the terrifying scale of reality without the comfort of illusion, subscribe and join us on this journey. We have only just breached the surface of the void. The discrepancy in our cosmic measurements is not merely a mechanical glitch or a calibration error inside a machine. It is a symptom of our imprisonment. We are entirely confined within a physical boundary known as the observable universe. To understand the sheer scale of this confinement, you must first accept a brutal limitation of physics. The night sky is not a spatial map of where things are right now. It is a historical archive written in the strict, unyielding latency of light speed. Light takes time to travel. Every time you look up, you are looking backward in time. When you look at the moon, you see it as it was a little over 1 second ago. When you look at the sun, you are witnessing a ghost that is 8 minutes old. If the core of our sun were to suddenly shut down and vanish right now, humanity would continue to orbit an empty, dead void in blissful ignorance for 8 uninterrupted minutes before the darkness finally hit us. This delay is the hard-coded server latency of our physical reality. If we project this latency out into the deep vacuum, we hit a hard, insurmountable wall. The universe has a finite age, roughly 13.8 billion years. Because light has an absolute maximum speed, there is a strict mathematical limit to how far away we can possibly see. We are trapped inside a sphere of causality. Anything beyond this sphere is fundamentally disconnected from our reality because its light simply has not had enough time to reach us since the dawn of creation. But space did not sit still and wait for that light to arrive. Space has been violently, continually expanding. While the oldest photons were traveling toward us, the physical fabric beneath them was stretching, dragging the actual edge of our observable bubble outward to a staggering 93 billion light-years in diameter. To map the exact borders of this 93 billion light-year cage, astrophysicists do not rely on standard glass lenses. We rely on the thermal capture of ancient, exhausted radiation. Consider the profound engineering required to operate the James Webb Space Telescope. To detect the microscopic heat signatures of the most distant ancient galaxies ever formed, the physical machinery of the telescope itself must be aggressively, violently silenced. If the sensors on the telescope were even slightly warm, their own internal heat radiation would completely blind the cameras, much like trying to spot a single firefly while standing directly in front of a blinding stadium floodlight. To achieve this silence, engineers designed a closed-loop acoustic cryocooler, a complex mechanical refrigerator pumping liquid helium through the heart of the observatory, dragging the temperature of the internal detectors down to minus 266 degrees Celsius. At this brutal, near-absolute zero temperature, the very atoms of the beryllium mirrors practically stop vibrating. The machine is essentially dead. It is cold enough and quiet enough to capture solitary photons of light that have been stretched out and cooled down by the relentless expansion of space over 13 billion years. What these frozen sensors reveal is an architecture of such monstrous, overwhelming scale that it completely obliterates the concept of human significance. The Milky Way galaxy alone contains up to 400 billion individual stars. It takes light 100,000 years just to cross from one edge of our galactic spiral to the other. Yet, when mapped by our deepest observations, our entire galaxy is reduced to a single microscopic node within a colossal cosmic structure called Laniakea. Laniakea is a supercluster. It is a sprawling, branched network of 100,000 separate galaxies, all bound together by invisible, massive filaments of dark matter, spanning over 500 million light-years in diameter. Imagine a sprawling, infinitely dense metropolis like Tokyo at midnight. If Laniakea is the entire city, our entire solar system is nothing but a single subatomic electron moving inside one specific light bulb in one specific room of one specific skyscraper. And this massive galactic city is not stationary, it is moving. The entire Laniakea supercluster, dragging the Milky Way along with it, is hurtling through the cosmos at a speed of over 600 kilometers every single second. The gravitational mathematics reveal we are in a state of freefall, plummeting toward a massive gravitational anomaly hidden deep within the Centaurus constellation. Astrophysicists call it the Great Attractor. It is a concentration of mass so impossibly dense, possessing the gravitational pull of tens of thousands of Milky Way galaxies combined, that it is warping the trajectory of millions of galaxies across 100 million light-years of space. We do not know exactly what the Great Attractor is, because our view of it is completely blocked. It sits directly behind the dense, dusty, irradiated core of our own Milky Way galaxy, a region astronomers simply call the zone of avoidance. We are essentially trapped in a vehicle driving at breakneck speed toward an unknown massive destination, and our own windshield is completely covered in opaque mud. Yet even Laniakea and the Great Attractor are just localized weather in the grander cosmic ocean. As we map the distribution of matter to the very edge of the 93 billion light-year sphere, we encounter the true, terrifying nature of scale. The observable universe, with its 2 trillion galaxies and uncountable octillions of stars, is entirely flat, incredibly uniform, and perfectly balanced. The temperature of the background radiation in one direction of the deep sky is identically matched to the temperature in the complete opposite direction, billions of light-years away. For these two isolated, opposite edges of reality to possess the exact same temperature today, they must have been in direct physical contact in the past. The only mathematical explanation for this uniformity is a violent, terrifying process known as cosmic inflation. In the first fraction of a microsecond after the universe began, space did not just slowly expand. It detonated. Reality itself multiplied its own volume by a factor so incomprehensibly massive that human language completely fails to capture the scale. Imagine a single microscopic grain of sand suddenly and violently expanding to become larger than the entire observable universe in less than a billionth of a blink of an eye. This extreme exponential inflation smoothed out all the chaotic wrinkles of early reality, leaving behind the vast, cold, flat expanse we see today. But the dark, inescapable consequence of this mathematical truth is what it implies about the space beyond our vision. If inflation is real, then the 93 billion light-year sphere we call the observable universe is not the universe at all. It is just a microscopic, localized pocket of light suspended in a much grander, darker structure. The mathematics of inflation demand that the unobservable universe is incredibly larger than the space we can see. Some conservative estimates suggest it is at least 15 million times larger. Many accepted models suggest the true physical volume of reality is completely infinite. A never-ending, shoreless ocean of dead galaxies, dark matter, and expanding vacuum that goes on forever, without any boundary, edge, or center. We are not just physically small, we are fundamentally locked out of reality. The vast, overwhelming majority of the universe is already completely inaccessible to us, hidden beyond an event horizon we can never cross. And the cage we are in is shrinking. Because of the accelerating expansion driven by dark energy, the space between us and the most distant galaxies is currently stretching faster than the speed of light. This means the photons emitted by those distant galaxies right now will never, ever be able to cross the expanding gap to reach our telescopes. They are currently slipping over the cosmic horizon, fading into absolute, permanent blackness. Every single day, entire galaxies and star systems vanish from the observable universe forever, swallowed by the accelerating void. We are being actively, deliberately erased from the grander cosmic landscape, isolated in a darkening bubble where the external reality is retreating faster than our biology could ever hope to pursue. The fading of distant galaxies beyond our visual horizon is a physical isolation, a slow and agonizing blinding of our species. But the true terror of our existence is not merely that we are locked inside a shrinking bubble. The ultimate insult is that we do not even understand the floor we are standing on. When we retreat from the cosmic expanse and attempt to dismantle the fundamental machinery of our local reality, we do not find elegant answers. We find a shattered mirror. We find a set of physical laws that are actively, violently at war with each other. Our entire modern technological civilization, every satellite in orbit, every microchip processing data, and every medical imaging device is built upon two absolute pillars of physics. The first is Albert Einstein's general relativity, the supreme law of the macrocosm. It dictates the sprawling, elegant geometry of gravity, describing a universe where space and time are woven into a smooth, continuous fabric. It is a deterministic world. If you know the mass and velocity of a planet, you can predict its exact location 1,000,000 years from now with flawless precision. The second pillar is quantum mechanics, the sovereign law of the microscopic. It governs the behavior of atoms, electrons, and the subatomic forces that bind matter together. But unlike the smooth, predictable silk of general relativity, the quantum realm is a chaotic, boiling casino of probability. At the subatomic level, particles do not possess fixed locations or exact trajectories. They exist in a blurry state of statistical likelihood, only deciding where to be at the exact moment they interact with something else. These two frameworks are completely incompatible. They are like trying to run two radically different, aggressively hostile operating systems on the same computer simultaneously. If you try to use general relativity to describe an electron, the math becomes meaningless. If you try to use quantum mechanics to calculate the orbit of Jupiter, the equations output pure gibberish. For decades, physicists survived this contradiction by simply keeping the two theories separated. You use relativity for the massive and quantum mechanics for the tiny. But the universe does not allow this segregation to last. There are places in the dark where the cosmos forces the massive and the microscopic to occupy the exact same physical space. And when it does, the mathematics of reality completely collapse. Consider the death of a hypergiant star, a massive fusion engine dozens of times heavier than our own sun. When it burns through its nuclear fuel, the outward pressure of radiation stops, and gravity, the most relentless force in nature, takes absolute control. The star's core, millions of miles across, is crushed inward at a fraction of the speed of light. The sheer inward violence overcomes the repulsive force between atoms. It overcomes the quantum resistance of electrons. It crushes protons and electrons together into a dense ball of neutrons, and then it overcomes that resistance too. Gravity wins a total, infinite victory. The entire mass of the star is compressed into a physical point of zero dimensions. Zero height, zero width, zero depth. Astrophysicists call this the singularity, but a singularity is not an actual, physical object. It is a mathematical error code. When you attempt to calculate the density of a mass compressed into zero volume, you must divide by zero. In the cold logic of physics, infinity is not a number. It is nature's way of explicitly telling you that your theory has broken down. The equations of general relativity predict a curvature of space-time so extreme, so steep and bottomless, that all known laws of physics are instantly shredded. We cannot see this breakdown, because the universe actively hides its most shameful mathematical errors behind an impenetrable shield. The event horizon. This is the boundary surrounding the black hole where the escape velocity exactly equals the speed of light. Because nothing can travel faster than light, nothing can return. If you were to cross this threshold, you would not just be trapped in space, you would be trapped in a collapsed architecture of time. Inside the event horizon, the geometric fabric of reality is warped so severely that space and time literally swap their fundamental properties. The singularity is no longer a physical location in front of you. It becomes an unavoidable moment in your inevitable future. You can no more avoid moving toward the singularity than you can avoid tomorrow from arriving. Yet, the existential dread of the black hole is not found in the singularity itself. The true nightmare emerges at the very edge of the abyss, right on the razor wire of the event horizon, where quantum mechanics and general relativity are forced into a deadly, unresolvable conflict. This conflict creates the information paradox, a theoretical crisis that threatens to destroy the very foundation of science. To understand the paradox, we must look at empty space itself. According to quantum mechanics, the vacuum is never truly empty. It is a restless, seething ocean of virtual particles. Constantly everywhere, pairs of particles and antiparticles spontaneously pop into existence, borrowing energy from the vacuum for a fraction of a microsecond before instantly colliding and annihilating each other, returning the energy. This is a proven, measurable fact of our reality. But what happens when this quantum boiling occurs exactly on the boundary of an event horizon? In the 1970s, the theoretical calculations revealed a merciless truth. Occasionally, a pair of virtual particles emerges right on the microscopic edge of the void. One particle forms just inside the event horizon, and the other forms just outside. The particle on the inside is instantly dragged down into the singularity, trapped forever. The particle on the outside, having lost its partner, cannot annihilate. It is violently ejected out into the cold universe as real physical radiation. The math dictates that the energy required to create this escaping particle is physically stolen from the black hole itself. The conclusion is inescapable and terrifying. Black holes are not immortal. They are leaking. They are slowly, agonizingly bleeding their mass away into the void as microscopic thermal radiation. And the mathematics reveal another merciless truth. The smaller the black hole becomes, the steeper the space-time curve at its horizon, and the hotter it burns, exponentially accelerating its own evaporation until it violently explodes into nothingness. If a black hole eventually evaporates entirely, we are left with a catastrophic problem regarding the fundamental ledger of reality. In physics, there is an absolute sacred law known as unitarity. It dictates that quantum information cannot ever be completely destroyed. If you write a secret on a piece of paper and throw it into a roaring furnace, the physical paper is gone, but the information is not theoretically lost. If you possessed a supercomputer powerful enough to track the exact trajectory of every single molecule of smoke, every photon of light, and every fleck of ash ejected from the fire, you could run the laws of physics in reverse and perfectly reconstruct the secret. The universe always keeps the data. But if you throw that same piece of paper into a black hole, the information is locked inside. Trillions of years later, the black hole evaporates completely, leaving behind nothing but random, chaotic, featureless thermal radiation. The radiation contains no structure, no memory, and no record of the paper, the star that collapsed, or anything else that ever fell in. The black hole acts as a cosmic incinerator that permanently deletes data from the universe. If quantum information is truly destroyed, then quantum mechanics is fundamentally wrong. If the information is somehow preserved in a way we cannot see, then general relativity is fundamentally wrong. There is no middle ground. The most brilliant minds on the planet have spent half a century throwing complex theoretical mathematics at this paradox, inventing holographic principles and multidimensional string theories, but the barrier remains. We are staring at a locked door, and the key is made of a metal we have not yet discovered, and the collapse of our understanding extends far beyond the edges of black holes. The deepest, most offensive paradox in modern physics lies in the very emptiness of the room we are sitting in. It is called the vacuum catastrophe, and it represents a failure of human comprehension so vast that it makes the distance to the furthest galaxy seem trivial. When astrophysicists measure the accelerating expansion of the universe, they calculate the density of the dark energy required to push space apart. It is a very specific, incredibly tiny amount of energy per cubic meter of vacuum. However, when quantum physicists calculate how much energy should naturally exist in that exact same cubic meter of empty space, based on the violent, constant boiling of virtual particles we just discussed, the resulting number is not just different, it is apocalyptic. The quantum calculation predicts that the energy inherent in a single cubic meter of empty space is so massive that it defies practical analogy. It is roughly 120 orders of magnitude larger than what astronomers actually observe. 120 zeros. This is universally recognized as the single worst prediction in the entire history of theoretical physics. If the quantum calculation were correct, if the vacuum of space actually contained that much raw, seething energy, the universe would have violently ripped itself apart the moment it was born. The repulsive force would be so absolute that no two atoms could ever have bonded together. Stars, galaxies, planets, and biology would be fundamentally impossible. The physical reality we observe demands a calm, nearly empty vacuum, yet the mathematical rules that govern our atoms scream that the vacuum should be a raging inferno of energy. Imagine hiring an engineer to estimate the weight of a single raindrop, and they return with a mathematical proof, claiming it weighs exactly as much as the entire planet Earth, the Sun, and every star in the Milky Way combined. That is the scale of the mathematical failure we are currently living inside. We are forced to confront the terrifying likelihood that our physical laws are not universal truths. They are merely localized approximations. They are rough, low-resolution sketches made by biological creatures completely unequipped to perceive the actual high-definition architecture of reality. We are trying to decode an encrypted alien signal using a wooden abacus. The harder we push against the boundaries of the extremely massive and the infinitely small, the more the illusion of our understanding violently shatters, leaving us stranded in a cosmos that is inherently hostile to logic itself. To confront the paradoxes of the cosmos is to realize that our physical isolation is only the beginning of the tragedy. The breakdown of quantum mechanics and general relativity at the edge of the abyss, and the violent disagreement in the expansion rate of the universe, are not merely puzzles waiting to be solved. They are the symptoms of a terminal diagnosis for reality itself. The accelerating expansion of space and the relentless rule of thermodynamics guarantee a future so profoundly desolate that it fundamentally alters the meaning of existence, time, and memory. We must first abandon the comforting illusion of a universal clock. Because space is vast and the speed of light is rigidly finite, there is no such thing as a shared present moment. The concept of now is a biological fiction, a localized hallucination engineered by our brains to process immediate surroundings. When you look across the cosmos, you're looking through a graveyard of different eras, but the expansion of the universe adds a far more sinister layer to this temporal fracture. As dark energy stretches the fabric of reality, driving galaxies away from us at speeds exceeding the velocity of light, it does not just push them out of our physical reach, it exiles them from our timeline. When a distant galaxy crosses the cosmic event horizon, it does not suddenly blink out of existence. The physics of relativity dictate a far more agonizing departure. As the space between us and the galaxy expands faster than light, the photons it emits are forced to swim against an overwhelming cosmic tide. The light is stretched, its wavelength elongating further and further into the infrared, then into microwaves, and finally into faint, undetectable radio waves. To an observer on Earth, the galaxy appears to slow down. Its time seems to freeze. It fades into a dark red ghost, forever lingering on the edge of the horizon, while the actual physical galaxy has long since been carried away into the unreachable void. We are surrounded by phantoms. The vast majority of the universe we can see is already a hallucination of dead light. But what of our local neighborhood? What happens to the matter that is close enough to resist the pull of dark energy? Gravity is a stubborn force, and it has temporarily secured a tiny, localized island of structure for us. The Milky Way, the Andromeda Galaxy, and a few dozen smaller dwarf galaxies are gravitationally bound together in a cluster known as the local group. We are locked in a mutual embrace, anchored against the expansion of the grander universe. But this anchor is not a sanctuary, it is a collision course. Right now, Andromeda is hurtling toward the Milky Way at 110 kilometers per second. In roughly 4 billion years, these two colossal structures will meet. But because the distances between individual stars are so grotesquely vast, the galaxies will not crash like solid objects. They will pass through one another like ghosts in the dark. The gravitational tidal forces will violently warp their spiral arms, tearing streams of stars out into the intergalactic void. Over hundreds of millions of years, they will dance a slow, chaotic ballet, passing through each other multiple times before their supermassive black holes finally spiral inward and merge. The beautiful, distinct spiral shapes of both galaxies will be permanently erased, leaving behind a single, amorphous, featureless, elliptical galaxy. Astrophysicists have already named this future tomb. They call it Milkomeda. Once Milkomeda stabilizes, the true agonizing consequence of dark energy will become apparent. As the universe continues to accelerate, every other galaxy outside our local group will eventually be pushed past the cosmic horizon. The acceleration will become so extreme that the light from the rest of the universe will simply never reach us. The night sky, which has been a canvas of countless distant galaxies since the dawn of humanity, will go completely, irreversibly black. Imagine a civilization born on a planet in Milkomeda hundreds of billions of years from now. When their astronomers build telescopes and look up into the deep void, they will see absolutely nothing but their own local stars. They will not see the cosmic microwave background radiation, because it will have been stretched so far that it is entirely undetectable. They will not see other galaxies retreating, because they will have already vanished. This future civilization will have zero physical evidence that the universe is expanding. They will possess no clues about the Big Bang. They will look at their isolated dying galaxy and logically, scientifically conclude that their small cluster of stars is the entire universe, sitting static and eternal in an infinite, empty dark. The universe is actively erasing its own history. We exist in a vanishingly narrow, privileged window of time, a brief cosmic coincidence, where the universe is old enough to have formed intelligent life, yet young enough that the evidence of its own violent birth has not yet been scrubbed away. But even Milkomeda cannot survive the relentless, grinding machinery of entropy. The second law of thermodynamics is the ultimate, undisputed dictator of reality. It dictates that all closed systems degrade, that order inevitably decays into chaos, and that heat relentlessly dissipates into cold. The universe is a clockwork mechanism that is winding down, and it has no mechanism to rewind. We are currently living in the stelliferous era, the age of starlight, but this era is a fleeting spark. Star formation has already peaked and is currently dropping at an exponential rate. The heavy, brilliant blue stars die quickly, detonating in a few million years. The sun-like stars will burn out over billions of years, swelling into red giants before shedding their atmospheres and leaving behind naked glowing cores known as white dwarfs. The last remaining lights in the universe will be the red dwarfs. These tiny, hyper-efficient stars hoard their hydrogen, burning at a slow, agonizing crawl. But even they have a limit. Roughly 100 trillion years from now, the very last red dwarf will exhaust its fuel. It will quietly extinguish without a sound. At that exact moment, the universe will go completely dark in the visible spectrum. The age of starlight will permanently end. Reality will plunge into the degenerate era. The cosmos will be populated entirely by stellar corpses. Brown dwarfs, white dwarfs, neutron stars, and black holes will drift blindly through a pitch-black, expanding void. The only illumination will come from the rare, random collisions of these dead bodies, creating brief, pathetic sparks of supernova light before plunging immediately back into the freezing dark. As the eons drag on, the physical universe will become so cold and so diffuse that the fundamental structures of matter itself may begin to lose their integrity. Theoretical physics suggests that protons, the heavy building blocks of all atomic nuclei, are not immortal. Over timescales spanning a non-illion years, a 1 followed by 30 zeros, protons may spontaneously decay. They will break apart into lighter subatomic particles and low-energy radiation. If proton decay is real, it means that the universe will literally forget how to maintain matter. The cold dead planets, the frozen iron cores of stars, the microscopic dust drifting in the void, everything that has mass and structure will slowly dissolve into a mist of radiation. The concept of solid objects will be deleted from physical reality. When the last atom dissolves, the universe will enter the black hole era. The only remaining macrostructures in existence will be the supermassive black holes. They will govern a universe of absolute silent darkness, acting as the final vaults of gravity. But as we learned from the terrifying mathematics of the event horizon, even these absolute titans are bleeding. Through the slow microscopic leak of Hawking radiation, these colossal gravitational engines will evaporate particle by particle. This process requires a length of time that shatters the limits of language. For a supermassive black hole to completely evaporate, it will take a googolplex of years. A number so large that if you tried to write it out, filling the entire observable universe with microscopic zeros, you would run out of physical space long before you finished writing the number. Yet under the cold, infinite patience of time, it will happen. As a black hole nears the very end of its life, it shrinks, burns hotter, and finally detonates in a flash of gamma rays, a microscopic silent firework in an ocean of eternal night. When the final black hole evaporates, the universe will enter the dark era. There will be no stars, no planets, no black holes, and no atoms. There will be nothing but a vast, infinitely expanding void, containing a sparse, incredibly dilute soup of photons, neutrinos, and subatomic particles drifting at absolute zero. The expansion of space will have driven these remaining particles so far apart that they will never ever interact with one another again. The universe will reach a state of maximum entropy, thermodynamic equilibrium. In this final frozen state, the concept of time itself breaks down. Time is only measurable through change. It is the observation of an event happening, of a state shifting from one configuration to another. But in the dark era, nothing happens. Everything is exactly the same, everywhere, forever. Without events, time loses all physical meaning. 1 trillion years and a single second become mathematically identical. The universe does not end in a fiery cataclysm. It ends in a whimper, a slow, quiet freezing, a permanent erasure of all data, all structure and all memory, leaving behind a blank, expanding canvas that will never be painted on again. The ultimate realization of our place in this architecture is not one of tragedy, because tragedy requires a spectator. It requires a universe that is capable of registering a loss. What we face is something far more profound. We face absolute structural indifference. For thousands of years, we have desperately tried to project our own biological importance onto the cold vacuum. We drew artificial lines in the sky, connecting random, unrelated dying stars to form the shapes of our terrestrial animals and our mythological gods. We convinced ourselves that the universe was a grand, deliberate theater, and that the Earth was the center stage, built specifically to harbor our existence. But the physics and the cold mathematics have systematically dismantled that illusion. We now know that the universe does not notice us. It does not possess a mechanism to care about our presence. We are a brief, highly improbable chemical reaction occurring on the moist surface of a tiny silicate rock, orbiting a painfully average star, drifting in the quiet, dusty suburbs of a galaxy that is currently falling toward an invisible anomaly in the dark. Our consciousness, the very neurological machinery that allows us to measure the expansion of space and calculate the decay of the proton, is not the pinnacle of cosmic evolution. It is a temporary, localized glitch in the entropy of the universe. It is a biological anomaly that will eventually be corrected by the relentless, grinding laws of thermodynamics. The fact that we can comprehend the terrifying scale of reality does not give us power over it. It only isolates us further. We are the only mechanisms in the observable universe capable of understanding our own guaranteed erasure. We possess the mathematical vocabulary to calculate exactly how and when the lights will go out, yet we possess absolutely zero mechanical power to stop it. This is the true existential friction. We are awake in a universe that is completely asleep. The next time the rotation of the Earth plunges your hemisphere into shadow, do not look up at the stars and imagine a welcoming frontier. You are looking into the open jaws of a machine that is violently tearing itself apart. You are witnessing the aggressive, physical expansion of a void that will eventually swallow every trace of our history, our architecture, and our understanding. The stars you see are not beacons of hope. They are burning spheres of plasma, desperately expending their finite fuel, violently screaming against the crush of their own gravity, only to eventually succumb to the cold. The black between those stars is not an empty canvas. It is a swelling, pressurized ocean of phantom energy that is actively pushing the rest of reality out of our reach. There is no grand cosmic design waiting to be uncovered. There is no hidden equation that will suddenly make the universe center around our survival. There is only the ambient temperature of the vacuum, the speed of light, and the relentless, one-way march of entropy. We occupy a vanishingly small fraction of space for a vanishingly small fraction of time. Soon the cosmic horizon will close in around us. The distant galaxies will fade into permanent obscurity. The stars will quietly exhaust their remaining fuel. The very atoms that constitute our ruins will dissolve back into the freezing dark. The universe will not remember that we were here. It will not record our struggles, our mathematics, or our despair. The silence that follows will not be a peaceful rest after a long journey. It will be the total, permanent default state of a reality that has finally returned to equilibrium. The void does not hate us. The void does not love us. The void simply is. And in the face of that absolute frozen dark, there is nothing left to do but watch the light while it lasts.